Okay, so let's look at this next characteristic. The next characteristic is talking about vertical shifts. You know which way vertical goes. It goes up and down, which means if it goes up and down, it's affecting which variable? That's correct, the y's. So here's what I need you to notice. Notice I tacked on this plus c now. So in this particular case, when I tacked on the plus c, did I put any parentheses around the bx and the c? No, I didn't, which means that c is not affecting the x's. It's still affecting the y values. Got it? There's no parentheses keeping those together, which means the plus c is outside the x's, which means it's affecting the y values. If it's affecting the y's, that means it's also going to affect your, that's right, it's going to affect your range. Now, mind you, this is another way that can be written. Sometimes they put that number, that vertical shift, that c, in the beginning. And it's very obvious that it's not affecting the x's. So sometimes this is the better way that some of you may want to write it. If they give you the plus c at the end and you're like, oh my gosh, that's confusing me because I keep thinking it's attached to the x, then rearrange it so you write the c first, whatever that number is. Cool? Okay, so let me get a problem down here for us to work on. Okay, well, where do we start? That's right, I heard some of you say it. You start with the amplitude. What's my amplitude in this case? Boy, I hope you said a positive one because amplitude is always positive. And the amplitude gives you the range. And so in this case, my range is, that's right, inclusive from -1 to 1. After the amplitude, you then identify if it flips. Will this one flip? Yes, it will, because I have a negative in front, which means cosine is usually the graph of a what? It's a valley. But if you flip it, it becomes a mountain. So I should have a graph that looks something like that, right? Okay. Period is next. Agreed? So, the period is taking 2 pi and dividing by 3. By the way, I need to make a note to you. I need you to note something I should say. Period is always positive. I know we have a negative rotation around the circle, so to speak, but when we talk about period, we always go in the positive direction. The period is always a positive rotation. So just FYI on that, okay? Okay, so when you identify the period, you should also identify what? Good. The length of each interval. And how do I find it? I take the new full angle length of a circle, the new rotation, the new full angle rotation of a circle, which in this case is 2 pi over 3, and you're going to do what? Good, you're going to divide by 4. And when you do that, you have to remember to multiply by the reciprocal, right? Which, yep, 2 pi over 12, which reduces to pi over 6. So the length of each interval will be pi over 6. Good? And now I've got one new piece of the puzzle to look at. I need to look at a vertical shift. Do we have a vertical shift? And you're like, well, okay, so, you know, go back to the parabola. If you had y, pardon me, if you had just y, not y squared, if you had y equaling x squared minus 4, did that have a vertical shift? Yeah, that minus 4 told you it went down 4, didn't it? Well, do I have a vertical shift? The answer is yes. As a matter of fact, it's going which direction? Yeah, since it's a positive 2, it's going up 2 spaces. So help me out. Since this whole graph is shifting up 2 spaces, the y's are being affected, which means your range is being affected. So I have a new range to deal with or to identify. I'm like, well, how do you get it? Let's think about it. If the old one started at -1 and it's shifting up 2, that means if I take -1 and add 2 to it, what do you get? Good. You get +1, don't you? If the old range ended at +1 and it's shifting up 2 spaces, that means you're adding 2, which means the new range is going to end at 3. Cool? Okay, so let's see what this graph looks like. By the way, I'm going to get myself a little bit of board space so we can see it just a little clearer, especially if we've got some work that we want to show on the board, right? Okay, so you start drawing your number line, I should say, your x-axis and your y-axis, your grid system, and I am going to get mine up here. So it is going to, my range is now +1 to +3. I don't care about the negative down here any longer. I still have 4 intervals, right? But I'm still starting at 0 because there was no horizontal shift, right? There was only a vertical shift. So I'm still starting at 0. Now to get here, the length of each interval is pi/6, isn't it? So what's 0 plus pi/6? Good, pi/6. And then to get from pi/6 to the next one, you have to add pi/6 again, isn't it? Don't you? So pi/6 plus pi/6. Good, that's 2 pi/6. But doesn't that reduce? Good, it reduces to pi/3. And then to get from pi/3 to the next one, you still have to add pi/6, don't you? So, what's 2 pi/6 plus 1 pi/6? Good, 3 pi/6, which gives you, yep, pi/2, doesn't it? And last but not least, you got one more. You have to take 3 pi/6 and add one more pi/6 to it, which gives you 4 pi/6. Yep, that reduces to 2 pi/3, which from 0 to 2 pi/3 has a length of 2 pi/3 radians. Good? Okay, cool, loving it. Now, time to graph. You ready? Remember, when you plug these in, you will always end up at 0, pi/2, pi, 3 pi/2, and back to 2 pi. Remember that. You are always going to end up with those normal 5 radian measurements. Got it? Okay. So, my equation, let me just rewrite it over here. It might be a little bit easier to see. And I left the parentheses because that's where the x is. That's the numbers we get to plug in, right? Those are the new radian measurements we get to plug in. Okay, so first one we're plugging in is 0. So, 3 times 0. Yeah, that's 0. Cosine at 0. Yep, 1. So let me write this down because some of you want to see this, I know, right? So this will be 0, right? What's the cosine at 0? 1. So you've got -1 plus 2, don't you? Yep, that'll give me 1. Okay. And now I am plugging in pi over 6. And pi over 6 times 3. Yep, pi over 2. And what's the cosine at pi over 2? Yeah, that's a 0. So what's a negative 0 plus 2? Yeah, it's 2. Huh. That's kind of interesting. 2. All right. Next thing you're plugging in is, yep, pi over 3. And what's 3 times pi over 3? Back to pi. We knew we should have ended up with a pi here. Cosine of pi. Good, that's negative 1. With a negative in front of it, right? Because this is this negative, which gives me a positive 1 plus 2. That gives me a 3. Back to pi over 2. Yep, 3 pi over 2. What's a cosine of 3 pi over 2? Excellent. That's 0. Negative 0 plus 2. Yep, that's 2. And last but not least, 2 pi over 3. Gives you 2 pi. Cosine of 2 pi. 1 times a negative plus 2. Yeah, right here. So, did I get the upside down graph of cosine like I said I was supposed to? I sure did. Now, here's the thing. There's one other piece of information that this vertical shift is telling me that I can actually identify. Not only did we get the new range of 1 to 3, but if you look at all the other cosine and sine graphs that we did prior to this one, wasn't this x-axis cutting through the middle here? Well, here's the deal. If this plus 2 shifted my y's, which shifted the range, it also shifted the x-axis. Right here is what I call the new center line. And the new center line is, since this is horizontal, the new center line is y equals 2. Remember, the x-axis is also known as y equals 0. And if you shift that 2, you'll end up with y equals 2. So a couple of things happened on a vertical shift. The center line moved up 2 spaces, and my range moved up 2 spaces. Cool? Hang in there, got another example. Okay, so let's look at this problem. They're asking us to graph, so where do we start? Excellent, you start with the amplitude. So in this particular case, your amplitude is good. It's the number in front of, it's the coefficient of the trig function. So my amplitude is 2. What does that tell me? That tells me the range. So my range goes from, that's right, inclusive, negative 2 to 2, right? What's the next question? Right, does it flip? Does it? Some of you said yes. If you said yes, that told me you looked at the first number. Remember, what tells me if it flips is the sign of the amplitude. And that is a positive, so the answer is no, it doesn't flip. So I'm going to get my typical sine graph, which is the mountain to the valley. Got it? Be careful about that. Okay, next is the period. That's right, we're going to take 2 pi and divide it by the coefficient of x. What's my coefficient of x? Yep, that's a 1. So divided by 1, which is just 2 pi, isn't it? And now I get the length of each interval. So you're going to take the 2 pi, that's right, and divide it by 4, which means the length of each interval is pi over 2. So it's a typical length, isn't it? Because the period was 2 pi. So that's our typical angle in one full revolution of the circle. Excellent. And then we decide, or we figure out, that's right, a vertical shift. So does this have a vertical shift? Yes, it does. Notice this plus 3. They wrote it in front here, didn't they? I remember I mentioned to you in the last graph that they could write it in front or behind. They wrote it in front. The answer is yes, and it goes down 3 spaces, doesn't it? So what does that tell you? Good, that tells us a new range. So my original range started at -2. Well, if it goes down 3, that means my new range is going to start at -5, isn't it? The old range started at 2, but if you go down 3, that means it ends at -1, doesn't it? Okay, the new center line. Remember, there's a new center line. What was the old center line? Yeah, the x-axis, which was also, I'm just going to write it here, the center line was your x-axis, which is also known as y = 0. But if that goes down 3, then your new center line is, good, y = -3. Cool? All right, let's see what this looks like. So, it's looking like the graph is going to be below, whoops, below the x-axis. My center line is y = -3. Okay. I still have the 4 intervals that we work with. We're still starting at 0. I'm going to write these up here. Pi over 2, right? Because that's the length of each interval. So these aren't changing. These are the typical ones because the period was still 2 pi. So that hasn't changed from the very original one, right? From the original, I should say. Okay, so let's see what this graph is going to look like. We are going to plug in 0. And I'm going to write this down here so you can see the equation just a little bit better because we have a lot of stuff going on up at the top. So, and I am, instead of writing x, I'm going to do like I've been doing for the last few problems. I'm going to put parentheses there so we know we're plugging in the angle measurements here. So the first angle measurement we're plugging in is 0. So what's the sign at 0? Good, 0 times 2, 0, plus -3, -3. And now we're plugging in pi over 2. What's the sign at pi over 2? 1 times 2, 2, plus the -3, -1. Plug in pi. The sign at pi is 0. 2 times 0, 0. Plus -3, -3. 3 pi over 2 is next. What's the sign at 3 pi over 2? -1 times 2, -2, plus -3, -5. And last but not least, back to 2 pi. What's the sign at 2 pi? 0 times 2, 0, plus -3, -3. So we did get the mountain to the valley graph. And yeah, everything is coming out like it's supposed to, right? Y = -3 is the center line, isn't it? Cool? With me? Okay. We have one more characteristic to deal with graphing cosine and sine functions, so hang in there. Okay, so the last characteristic we're going to deal with graphing cosine and sine functions is what's known as a horizontal, or sometimes they call it a phase shift. So be aware, if they say phase shift, that's the same thing as a horizontal shift. So notice in this case, there's a new variable called d. Do you notice d is inside the parentheses with x? Well, since it's inside the parentheses with x, that means it's affecting the x's, which means that's going to go left and right. Are you with me? Okay. Now, Again, the C could be written first or it could be written last. So let's just make sure we understand that. So let me write down a problem, and we're going to take it from there. Okay, so we're like, well, where do we start? Back at the beginning, amplitude. My amplitude is what? Yeah, it's a 1, which tells me my range, which would be from -1 to 1. I ask myself, does it flip? The answer is no, because that 1 is positive. And cosine is a valley graph, so I better get a valley graph, right? And then I talk about the period. And the period is 2 pi divided by the coefficient of x, which is 1, so it's just 2 pi. The length of each interval would be 2 pi divided by 4, or just pi over 2. So this is our typical length of the circle and radian measurement. The next thing we identify is a vertical shift. Do I have a vertical shift? No. There's nothing added, right? There's nothing added at the end. There's nothing added at the beginning, so there's no vertical shift, which means my range is still going to be from -1 to +1 inclusive. So yay for that, okay? And then finally, we're going to deal with the phase shift. Is there one? Yes, because I have a number inside the parentheses with the x. Now here's the thing. Depending upon the authors of the book, there's actually a couple of different ways you could find the phase shift. I'm going to show you the way I like best, because it actually shows me what is my first radian measure I'm starting with and what's the last radian measure that I'm going to be plugging in, okay? So, bear with me, just hear what I have to say first. And I'm going to write it up here. The normal start and end is from 0 to 2 pi. Agreed? In this case, I have an x minus pi over 4. So I have an extra number inside with the x. Agreed? So I have to see what that does to the 0, which is my typical start, and what that does to the 2 pi, which is my typical end. So I am going to add pi over 4 to all three sides, which means we are going to start at pi over 4, and we are going to end at, okay, we got to add. So what's 2 pi plus 1 pi over 4? Well, maybe the better question is, what's 2 plus a quarter? Yeah, that's 9 pi over 4. So you have to remember how to add 2 and a quarter, right? So my phase shift, we are going to start at pi over 4, and we are going to end at 9 pi over 4. Now, quick question, because we got to make sure, we have to do a double check, because the period is supposed to be 2 pi, right? Which means from here to here should be a length of 2 pi. So if I take the larger angle minus the smaller angle, I get, that's right, 8 pi over 4, which is 2 pi. So check, that worked out. We did it right. Yay for that. Cool? Okay, loving it. Now, I need some board space to graph, so bear with me. So now that I've erased the board, let me get our graph system going here, okay? We know that our range is from -1 to +1. It's not flipping. A normal period, 1 full rotation around the circle and angle measurement is 2 pi, so that's typical. Pi over 2 is the length of each interval. And according to the phase shift, because there's no vertical shift, according to the phase shift, I'm actually starting at pi over 4. So here is my first angle measurement that I need to start with is pi over 4. And I'm still going to have 4 intervals. So there's 1, 2, 3, 4 intervals. And this one should end at 9 pi over 4. Are you with me? Okay, so I'm supposed to start at pi over 4. The low e, the length of each interval, is pi over 2. So, what's 1/4 plus 1/2? That's basically what you're adding, isn't it? Okay, you take care of your fractions, I'll take care of mine. That's 3 pi over 4, isn't it? So now I have to take 3 pi over 4, and I have to add to it that low e, which is pi over 2. Okay, you add your fractions, I'll add mine. Good. 5 pi over 4. And then I'm going to take 5 pi over 4, add that low e of pi over 2 again. What do you get? Good. 7 pi over 4. And last but not least, you got to take 7 pi over 4 and add pi over 2. And what do you get? And thankfully we get 9 pi over 4. If we didn't get 9 pi over 4, then we did something wrong and we better figure out what happened. Good? Okay. So, here is my function that I'm looking at. Now, I'm going to give myself some board space to work with here because I want you to see what you have to do because you've got to plug in each of these radian measurements for x, don't you? And as soon as you plug them in for x, the first thing you're going to do is subtract that 1/4 from it. So remember that. Okay, I've got a subtraction problem to do first. So, here's my parentheses, right? We've got the cosine of whatever minus a 1/4. Pi over 4, plug it in. What's pi over 4 minus pi over 4? Yeah, 0. Well, yay for that. So I'm taking the cosine at 0, which is 1. Remember, that's at pi over 4. Don't put it over here. We didn't start at 0, so don't even put the 0 on your graph. That's going to mess you up. Pi over 4, we got a 1. Then I plug in 3 pi over 4. Well, what's 3 pi over 4 minus 1 pi over 4? Yeah, 2 pi over 4, which reduces to pi over 2. You know the cosine of pi over 2. That's right, it's 0. Okay, so now you're plugging in what? You're plugging in 5 pi over 4. So, when you plug in 5 pi over 4 minus 1 pi over 4, 4 pi over 4, which is pi. What's the cosine of pi? -1. 7 pi over 4? Yeah, there's 6 pi over 4, which is 3/2. That's 0 when you take the cosine of it. Can you guess where the 9 pi over 4 y value is going to be? Yeah, it's going to be back up here at 1. You pretty much know the pattern. As long as the first 2 or 3 are in place, the last one should fall into place too. There is your cosine graph, and it had a phase shift, and it started at pi over 4. So check it out. Your phase shift was to the right, pi over 4, wasn't it? Good. Hang in there. Got one more example. Okay, so let's look at this last problem. They're asking me to graph. Where do I start? Good. Amplitude. What's my amplitude? 3, which tells you your range, which goes from -3 to +3 inclusive. That means brackets. Next question you ask yourself is, does it flip? Yes, it does, because there's a negative in front. And this is a sine graph, so since it flips, it's going to go from the valley to the mountain, isn't it? Next question you ask yourself, or you find out, the next information is the period. So you're going to take 2 pi and divide it by the coefficient of x, which is 2. So you have a period of pi, right? And the lowy, you're going to take that pi and divide it by 4, aren't you? Good. Next thing, yeah, vertical shift. Do we have one? Yes, we do. It's going up 1, isn't it? Which means we have a new range, don't we? So, it started at -3, the range, but if it goes up 1, you're starting at -2. It ended at 3, the range, but if you add 1, it ends at 4, doesn't it? Okay? And we have a new center line, don't we? Good. Y equals 1, because the x-axis is shifting up 1, isn't it? And last but not least, that phase shift. Do we have one? Yeah, we do. Look what's in that parentheses, right? I have a plus pi over 2 added to it. There's a phase shift. So remember, our normal starting radian is 0. Our normal ending radian is 2 pi. And so we've got to see what happens to the 0 and the 2 pi. In those parentheses is 2x plus pi over 2. As soon as I saw that plus sign, I knew there was a phase shift. Now we've got to figure it out. So first things first, I have to solve for x. Good. So you minus the pi over 2 from everything, don't you? Which means I have 0, pardon me, not 0. I'm going to have a negative pi over 2, aren't I? So we have negative pi over 2 less than or equal to 2x less than or equal to, good, 3/2 pi, or 3 pi over 2. And then, that's right, you got to divide by 2, don't you? So, means you got to flip these over, right? Okay, so I'm going to get negative pi over 4 less than or equal to x less than or equal to 3 pi over 4. So it looks like my start and end changed to negative pi over 4 and 3 pi over 4. Got it? Okay. I got to do a check. I have to check the period. Remember, from negative pi over 4 to 3 pi over 4 is supposed to have a length of pi, because that's the period. I need to make sure that I've done things correctly, because if this doesn't give me a length of pi, then I've done something wrong. So let's check it out. I take the larger radian, 3 pi over 4, minus the smaller one, which is negative pi over 4. Oh, this looks like it's going to work out, right? Because I get to add those, which gives me 4 pi over 4, which is pi. Yay, it checked out. Check. Totally good to go. Loving it. Does this make sense? Okay, let's graph. So, we are at -2 on the range. We have a center line of 1. And we end up here at 4. All right, we start at negative pi over 4. Okay, I think I need to move something over. Well, let's see. So we're starting here at negative pi over 4, right? Remember, I have a total of 4 intervals. But I need to find out where the next one is before I start assuming it's over here. The length of each interval is pi over 4. So if I start at negative pi over 4 and I add pi over 4, what do I get? 0. So my next mark is actually at 0. So here is one interval length. Now I know there's 2, 3, 4. Okay. So to the 0, I'm going to add pi over 4, right? Which gives us pi over 4. To this pi over 4, we add another pi over 4, which gives us pi over 2. And last but not least is pi over 2 plus a pi over 4. Yep, that's 3 pi over 4. Yay! Okay, so I need you just to see if you follow along. Because here's the deal. If I can get the first 2 and 3 of these to follow suit, because it's supposed to look like this, right? If I can get if the first 2 or 3 actually line up like they're supposed to, then the last 2 and 3 will also line up. Got it? Okay, so here's the deal. Here's my equation. And I have to first plug in a negative pi over 4. So 2 times negative pi over 4. And then I'm going to have to add pi over 2 to it. You know what I should get when I plug this in, right? What's the first radian you should get? Yeah, you should get 0. I better get 0, because if I don't get 0, then I've done something wrong. If this parenthesis doesn't work out to be 0, then I've done something wrong. So 2 times the negative pi over 4. Good. That's negative 2/4, which reduces to negative 1/2 plus pi over 2. Yay, that's 0. I should have gotten 0. If I don't get 0, I did something wrong. So what's the sign at 0? 0 times negative 3. 0 plus 1. 1, which is exactly where I should be ending up at. And let me get these guys out of the way, because they're going to make this look funny on the graph. I plug in 0 next. What's 2 times 0? 0 plus a half, or pi over 2? Pi over 2. So when I plugged in 0 here, my second radian was pi over 2, just like it was supposed to be. So what's the sign at pi over 2? 1 times negative 3. Negative 3 plus 1. Negative 2. Ah, and there it is. See? It's working, right? It's going down like it's supposed to. So at pi over 4, where should you be at? Yeah, you should be here at 1. At pi over 2, you should be at 4. And at 3 pi over 4, back here at 1. So this is the graph you should be getting. Good? Okay, so hang in there. I got just a little bit of a recap for us to make sure that you understand what's affecting. Okay, so here's the recap. Here is a generic cosine function I put up here, or it could be the sine function, doesn't matter. But here's the generic one with the A, B, C's, and D's. Now mind you, some authors of the book use Greek letters instead of A, B, C, and D. I'm going to tell you, it doesn't matter which variable they use, be it a Greek letter or an Aramaic letter that we're used to seeing. What matters is their location. First thing we dealt with was the amplitude. That was the coefficient of the trig function. It affects your y's. The second thing we dealt with was the period. That was the coefficient of the x. That affected the x's. The third thing we dealt with was the vertical shift. That was this number outside of the x's. It affected the y's. And last but not least, we dealt with the phase shift, which was D, which was located inside the parentheses. That affects x also. So 2 variables affect x, 2 variables affect y. Inside the parentheses, those numbers, which is your period and your phase shift, those affect your x's. two numbers. One is the coefficient of the trig function. One is completely outside the trig function. That's amplitude and vertical shift. Those affect your y's. So remember that. That's going to be key for you, especially when we get to a section where you're going to have to work backwards and you're going to actually have to find the trig function. And what's going to help you is knowing this stuff. So you have fun with this, and I'll catch you.